Hello everyone, my name is Michelle, and today we're going to be talking about the Pearson correlation coefficient, also known as R. So here is the formula for the correlation coefficient. R equals n times the sum of x times y minus the sum of x times the sum of y, all over the square root of n times the sum of x squared minus the sum of x squared, and all that times n times the sum of y squared minus the sum of y squared. And really quick, notice the difference between the sum of x squared right here and the sum of x squared right here. And the same thing with the sum of y squared and the sum of y squared. What does R even measure? Why do we want to know the correlation coefficient? So R measures how related x and y are, and it's measured on a scale of -1 to 1, where -1 shows an inverse relationship and 1 shows a direct relationship. So if we had an R of -1, our data would look something like this. These are our data points. And make a line something like that. You see where as x increases, y decreases, so that is an inverse relationship. Next, if we have a R of 0, our data points might look like this. And you see there's not really a line that we can draw from that, so if the R equals 0, we say that there's no correlation. And if the R equals 1, our data points might look something like this, and our line will look like that. So we can see that as x increases, y increases, so we say that has a direct relationship. So when we're calculating R from the formula, it's going to be some decimal between -1 and 1. So let's do an example. Here we have a table of height in inches and weight in pounds. So first we're going to need to label our x and y. It actually doesn't really matter which column is our x and y, but just for the sake of this example, I'll say height is x and weight is y. So according to the formula, we are going to need to find x times y, x squared, y squared, and the sum of x, the sum of y, the sum of x times y, the sum of x squared, and the sum of y squared. Alright, so I've made this little chart and we are going to fill it out. And you can see that these are just what we need to find, so we can plug them back into the formula. And before we begin, I recommend you get a graphing calculator because these numbers are going to get very large. Alright, so let's start on the first row of x times y. So the first row is 60 times 120, which is 7,200. The second row is 65 times 140, which is 9,100. The third row is 72 times 180, which is 12,960. The fourth row is 70 times 184, which is 12,880. The fifth row is 74 times 190, which is 14,060. And the sixth row is 63 times 160, which is 10,080. So next we are going to move on to the x squared column. The first row will be 60 squared, which is 3,600. The second row is 65 squared, which is 4,225. The third row is 72 squared, which is 5,184. The fourth row is 70 squared, which is 4,900. The fifth row is 74 squared, which is 5,476. And the sixth row is 63 squared, which is 3,969. Next, we're going to go to the y squared column. The first row is 120 squared, which is 14,400. The second row is 140 squared, which is 19,600. The third row is 180 squared, which is 32,400. The fourth row is 184 squared, which is 33,856. The fifth row is 190 squared, which is 36,100. And the sixth row is 160 squared, which is 25,600. Alright, so now that we've filled that out, we're going to find the sums. So I'm going to start on the very left and do the sum of x. So we're going to add up this entire column. 60 plus 65 plus 72 plus 70 plus 74 plus 63 equals 404. Now we're going to find the sum of y. 120 plus 140 plus 180 plus 184 plus 190 and plus 160 equals 974. Now we're going to find the sum of x times y. So that will be 7,200 plus 9,100 plus 12,960 plus 12,880 plus 14,060 and plus 10,080, which equals 66,280. Next, we're going to find the sum of x squared. I'm not going to read them out, but you add all those numbers, and we're going to get 27,354. And the sum of y squared, so all of those values added up, is 161,956. So yeah, now that we found our values, all we have to do is plug it into the formula and solve. So here is just everything we just wrote. The sum of x equals 404. The sum of y equals 974. The sum of x times y equals 66,280. The sum of x squared equals 27,354. The sum of y squared equals 161,956. And n, which is the number of columns we had, was equals 6. So now I am going to pull up the formula, and then we're going to plug these numbers in. Alright, here is our formula, and we are going to start plugging in. So r equals n, which is 6, times the sum of x times y, which is 66, 280, minus sum of x, which is 404, times the sum of y, which is 974. All of that over the square root of n, which is 6, times the sum of x squared, which is 27,354, minus the sum of x, which is 404 squared. And all of that multiplied by 6 times the sum of y squared, which is 161,956, minus the sum of y, 974, squared. So I'm going to put all of this into my graphing calculator, and I'm going to get that r is approximately approximately, because I'm rounding to 3 decimal points, 0.914. So yeah, that is our correlation coefficient. So what does it mean? We have a correlation coefficient of 0.914. So it's really close to 1. So that means that these two variables are strongly related, and they are in a direct relationship. So as x increases, y will increase. So yeah, that is Pearson's correlation coefficient. No conclusion this time, because it's really just taking numbers and plugging them into the formula. So yeah, I hope you learned something today and have a wonderful day. I'm actually recording this on the 1st of January of 2021, so I hope everyone has a happy new year.